video number 2. In the first video, I have revised with you end of term 2 material, which was related to, I think, differentiation. We covered everything. Now in this video, I'm gonna finish integration with you. Each and every question, we will do it together. And later on, when you will watch this video, you should open your revision pack and start solving with me. It will be a very, very good practice because I'm solving each and every question. So let's start with it. The first thing, Walaikum salam. The first thing which I want to teach the integration of exponential function, which is in our course. So integration of exponential function is the same as e raised to power x, but sometimes examiner gives you a linear factor here, and then we write the integration e raised to power ax plus b, and we have to divide the expression with the coefficient of x in the power of e, which is a, and don't forget to write plus c. So that's all within this concept. So we will solve all the questions together. The question number 1 is, I will try to solve them neatly, and you can also start working with Mr. Omar. E raised to power 3x minus 1 d of x. Now you can see we have a linear factor, a linear power. So what I'm going to do when I do the integration, I will write e raised to power 3x minus 1, but the coefficient of x, which is 3, I have to divide the whole expression by 3 and plus c. That's the question. I'll come to the B part. He says integration of e raised to power 4x plus 1. Again, check that he has given you exponential function with a linear power, linear expression in the power of e. So what we need to do, we write e raised to power 4x plus 1, and then what is the coefficient of x? 4. We need to divide the whole expression by 4. Don't forget, when we took the derivative of e raised to power 4x plus 1, at that time we were also writing the same answer, but in that case we were not dividing, the derivative of 4x plus 1. We were multiplying with the derivative of 4x plus 1, which was 4. So the derivative is e raised to power 4x plus 1, but the integration is you have to divide, but the condition is this: you have to have the power linear. There is no rule I have discussed with you. If you have 4x squared plus 1 d of x, no, that's not possible. You cannot solve it the usual technique which I have taught you. No, integration, but differentiation is possible. Differentiation of e raised to power 4x squared plus 1, same answer. And then the further derivative of 4x squared plus 1 is 8x. So the derivative is very simple thing. You can apply with the basic techniques which you have learned, but integration is very tricky. You have to go by the techniques which your teacher will be teaching you. So the third part, C, is e raised to power 0.5x plus 1. Again, you can see we have a linear power. What is the coefficient? Which is 0.5. So e raised to power 0.5x plus 1 divided by 0.5 plus c. Some students, if they want to write this in a whole power, this is 1 over 2. I can also write it as 2e 0.5 x plus 1 plus c. However, it is not very important for us. So this is the answer. This is the answer. This is the answer. And you can also write. But don't forget plus c. Now we go to the D part. E raised to power 5x plus 3. Same answer. The coefficient of x is pi. Need to divide it by pi plus c. E raised to power 4 x plus 1. d of x. Now you can see he has not expanded the bracket, so it's better to expand the brackets first. E raised to power 4x plus 4 t of x. And then now the question is ready to be integrated because we have a linear expression on the top. I will write the same answer and divided by the coefficient of x, which is 4. I divided by 4 plus c. Now the questions keeps on repeating, but f part is a little bit different. You put a radical sign on x plus 1, e raised to power x plus 1. I'm going to write it as e raised to power x plus 1 divided by 2. You can write it as, or you can also write it x over 2 plus 1 over 2 d of x. So boys, integration of this is same answer. What is the coefficient of x? The coefficient of x is 1 over 2. So I'm going to divide it by 1 over 2 plus c. If you want to make it furthermore beautiful, send the 2 on the top. So 2e, I can write half outside x plus 1 plus c. Next, after doing the f part, let's move on to our next target, g. G is integration of e raised to power 2 minus x. Wow. Now he is writing the coefficient of x minus 1.
Negative 2 minus.
Yeah. So 2 minus x, which is 1. So we should divide it by minus 1 plus e. Yes, Marzen, minus 1. And if you want to make it furthermore beautiful, you can write it as minus e2 minus x plus c. And then we go to the h part. H part integration of e raised to power 3 minus 2x d of x e 3 minus 2x. The coefficient, it's a linear. Coefficient of x is minus 2 divided by minus 2 plus c. That's all. And then finally, I part integration of e raised to power again. You put a square root 1 minus x. I'm going to write it as e raised to power 1 over 2 minus, and then e raised to power half minus 1 over 2x divided by 1 over 2 plus c. This 2 goes up. And then I write 2e half minus half x plus c. For the final examination point of view, you need to know, for example, if I write any number 5, e raised to power 2 minus 4x supposedly. So guys, this 5 will stay as it is. Okay, e raised to power 2 minus 4x. And what is the coefficient of x I have? Minus 4. So you need to divide it by minus 4 plus c. In a beautiful form, if you want to write it as minus 5 over 4, e raised to power 2 minus 4x plus c, and it will give you the 2 marks. Okay, guys. So these questions, I didn't write any coefficient at the back, but maybe in the final exam, you will have any coefficient back. So that's not a big deal. If he writes any coefficient, you just copy it as it is. So one skill has been done. Maybe in the exam, you will find a question where he gives you the limits. So it means that this is a definite integral because he gave you the lower limit and the upper limit. You just need to get your final answer. Don't write C. You need to substitute the upper limit and then minus lower limit. But since the examiner is willing to get the answer, yes, please. Yes, Mohsen.
Substituting first.
Yeah, don't substitute first, just get the integration and then we will solve this one. Suppose integration of e raised to power 3x is 3x divided by 3, but don't write plus c. You need to write the upper limit and lower limit. Here the integration of e raised to power 4x is e raised to power 4x divided by 4, upper limit and lower limit. Here the integration of e raised to power x minus 1 is over 1, upper limit and lower limit. Now we need to substitute the upper limit first, then minus lower limit. So we'll give you e raised power 3 over 3 minus anything power 0 is 1 over 3. And that is the final answer. Do you want to write as a single fraction? Okay, both of them are your final answers. Now substitute here upper limit e raised power 4, 0.25 over 4. This is my upper limit minus lower limit e raised power 4, 0 over 4. So this becomes e raised power 1 over 4 minus 1 over 4. And finally, I can write it as 4 as 1, yani denominator, e minus 1. Since he asks you to write the answer in the form of e, so I'm just keeping them in the e form. Otherwise, I can convert them into the decimal forms as well. Now, upper limit e raised power 2 minus 1 over 1. And then minus upper limit, lower limit e raised power 1 minus 1 over 1. And then gives me e over 1 minus e raised power 0 over 1. And then finally, it is e, and anything power 0 is 1. Final answer is e minus 1. Let's move on to our next target. Now, sometimes examiner uses lower limits and upper limits in the form of ln's. No worries. In the class, I have taught you very important thing. As in IGCSE, we studied f inverse f of x or f inverse of x. When they are confronting each other, you can cross them out and your answer is x. Same thing happens in the case of e and ln because they are inverse functions. So e ln of x, they can cancel each other and the answer is x. And if you are right, ln of e raised power x, e and ln cancel. And again, the answer is x. Or you can use the power property x goes back and ln of e is always equals to 1. Now, I'm gonna take the integration of e raised power x first of all. E raised power x is e raised power x, ln of 2 and 0. This is e raised power x, 2 ln of 3 and 0. E raised power x, ln of 3 and ln of 2. Now substitute the limits, e upper limit minus lower limit. Wow. E and ln will cancel each other and you get just 2. Anything power 0 is always equal to 1. The final answer is 1. Here, substitute the upper limit, 2 ln of 3 minus e raised power 0. Unfortunately, I cannot cancel ln with e because there is a 2. So use the power property of ln. So ln of 3 raised power 2 minus 1. Now ln and e will be cancelled. You got 3 squared minus 1, which is 9 minus 1, and the final answer is 8. In this case, when you substitute ln of 3 minus e ln of 2, now ln and e are confronting each other, cancel them, and you got 3 minus 2, and the final answer is 1. I hope it makes you understand very well. Next thing, wow. So exponential function, alhamdulillah, is thoroughly explained and well understood. Now we go to the another technique of integration. I'm going to write it for you. Whenever we have a linear expression in the denominator without any power. Okay, if this type of situation happens, its integration is ln of ax plus b, but please make sure you must have a linear expression in the denominator. This should be, again, I'm speaking, you must have a linear expression. Linear mean the power of x is 1. Okay, after writing ln of ax plus b, don't forget we love to divide with the coefficient of x, and the coefficient of x is a, so divided by a plus c. This is the technique which inshallah I will be using in dealing with these type of question, because there is one question in the exam coming on this topic. So it is linear. Wow, we can apply. It is linear. It is linear. It is linear. It is linear. 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 Wow, Mr. Omar. Kullu questions are related to this concept which I have just explained it to you. So let's start A part. The A part is 1 over 2x minus 1. So the answer is ln of 2x minus 1. Don't forget to divide with the coefficient of x, which is 2. So now divided by 2 plus c. So this is the a part. Let's do the b part. Integration of 2 over 2x minus 1. So, oh, important thing. This 2 will stay. Okay, 2 will stay. It won't change. So 2 ln of, since you have a linear expression, 2x minus 1. The coefficient of x is 2. So you should divide by 2 plus c. I'm going to cancel 2 with the 2. And my answer is just ln of 2x minus 1 plus c. So the b part is done. Let's go to the c part. Integration of 7 over 7x plus 3 d of x. Keep the 7 as it is because it is the coefficient. It is the coefficient, so keep it. And ln of 7x plus 3 divided by 7 because the coefficient of x is 7. So we need to divide plus c. 7 cancelled. My answer is ln of 7x plus 3 plus c. If you go to the d part, integration of 10 over 5 minus 2x. Now 10 will stay. ln of, we confirm, denominator is linear. 5 minus 2x. Here the coefficient of x is minus 2. I need to divide it by minus 2. Now minus 2 cancel with 10. Gives you minus 5 ln of 5 minus 2x plus c. Now the next part, it is e part. Minus 6 over 1 minus 3x. I write minus 6 ln of 1 minus 3x divided by minus 3 plus c. Minus 3 and minus 6 cancelled out. 2 ln of 1 minus 3x plus c. Then after that, we have the f part. F part is integration of minus 2 over 6x plus 5 d of x minus 2. Confirm linear. Yes. And then 6x plus 5 divided by the coefficient of x, 6. So this is 6. I'm going to cancel 2 with the 6. And that is minus 1 over 3 ln of 6x plus 5 plus c. After that, g part, integration of minus 3 over x plus 1 d of x minus 3 ln of x plus 1 x plus 1. Recording is still on. So minus x plus 1 divided by the coefficient of x, which is 1, plus c. I'm going to write minus 3 ln of x plus 1 plus c. So this is g part. And then we go to the h part, integration of 1 over 7 minus x d of x, which is ln of 7 minus x over the coefficient of x is minus 1. This is minus 1 plus c. I can write minus ln of 7 minus x plus c. So all the concepts which there was a single concept here, and we just did it by applying the integration rule when we have a linear expression in the denominator. He has also said that state the values of x for which the answer is valid. I think, guys, that is that can be related here because you remember the ln argument has to be positive. So 2x minus 1 has to be greater than 0. So you can explain it to the examiner that this is the valid region, but I don't think so. For the final exam, you need to concentrate on that. My actually focus is student needs to know how to find the integration of any particular expression. So now 2 techniques are discussed with you. I'm going to jump to the next expression. Next technique, integration of sine, integration of sine, integration of cosine, and integration of secant square. Okay, guys, and linear arguments. Linear arguments. So these are the integration of sine. You can also check on the formula sheet. It is minus cosine of ax plus b and divided by a, the coefficient of x. And the integration of cosine is sine ax plus b divided by a. And the secant square is integration is tan of ax plus b divided by a. So these are the formulas which you took it with me in the class. Now we will try to solve all the questions which are given here. The first question, he said, what is the integration of cosine of 2x? That will be sine of 2x divided by 2, because the coefficient of x is 2, so I need to divide it by 2, plus c. B part, sine of 2x plus pi by 4, very important. Integration of sine is minus cosine 2x plus pi by 4. Don't forget, we need to divide the expression by 2, the coefficient of x, plus c. C part, secant square 3x plus pi over 12 p of x. The integration of secant square is tan of 3x plus pi over 12 divided by 3. Again, the coefficient of x has to be divided. Now we're going to go to the D part. Integration of cosine of pi minus x. Integration of cosine is sine pi minus x. Remember, what is the coefficient of x? It is minus 1. So you have to divide by minus 1 plus c. E question is question cosine pi by 2 minus x over 4. The integration of cosine is sine pi by 2 minus x over 4 divided by, what is the coefficient of x here? Minus 1 over 4. So I can send this 4 up, becomes minus 4 sine of pi by 2 minus x by 4 plus c. Now we go to the F part. In the F part, he says integration of minus sine 2x minus pi by 4. Minus will stay. Integration of sine is minus cosine 2x minus pi by 4 divided by the coefficient of x, which is 2, plus c. So I got half sine 2x minus pi by. I go to the G part. Secant square pi over 12 minus 5x. Integration of secant square is tan pi over 12 minus 5x. What is the coefficient of x? Minus 5 plus c. G is done. Now we go to the H part. Integration of minus half sine of half x minus half as it is. Integration of sine is minus cosine half of x divided by half. Can I cancel half with the half? And I will be left with cosine of half x plus c. And I part, integration of cosine of 4 minus 1 over 3x. My integration of cosine is sine of 4 minus 1 over 3x divided by minus 1 over 3 because the coefficient of x is minus 1 over 3. Plus c, I can also write it as minus 3 sine of 4 minus 1 over 3x plus c. So that's all with this integration of trigonometric functions. Now there are some complicated trigonometric functions where we will use the trigonometric identities. Okay, so first these two results, we are not allowed to have square on the trigonometric sine and cosine. For this, we need to use a formula which is not provided in the formula sheet. But from the double angle identities, we can extract it. The double angle identity which I have taught you, that was cosine of 2x, it is equals to 1 minus 2 sine squared of x, and cosine of 2x is also equal to 2 cosine square of x minus 1. From here, I can make sine square of x as a subject, and from here I can make cosine square x as a subject. So check it out, it is equals to what? It is equals to 1 minus cosine of 2x divided by 2, and this is equals to 1 plus cosine of 2x divided by 2. So these results are called half angle identities. If you have here x, you get 2x, and these results are extracted from the basic double angle identities. Now allow me to erase this and then continue solving. I'll use these double angle identity results directly. Let's go with the A part. He said find the integration of cosine square of 2x. Then I will recall what is the integration of cosine square of 2x. Did we study this type of a result before? Yes, we have to use the half angle identity, which is equal to 1 plus cosine. Take the double of that. It's 2x. I need to write here 4x divided by 2 d of x. Now, friends, integration of 1 is what? 1. The integration of 1 is what? X. Okay. Plus integration of cosine of 4x is what? I think it's better. It's better to write 1 over 2 separate and cosine of 4x over 2 separate, and then do the integration. So the integration of half is half x, and half as it is. Integration of cosine 4x is sine of 4x, linear argument 4. We need to divide it by 4 plus c. The final answer comes into me half x plus 1 over 8 sine of 4x plus c. That's the final answer for this cosine square of x. Now come to the b part. Sine square 3x. Again, I'm going to use the half angle identity. Sine square 3x is 1 minus, take the double of 3x. What is the double of 3x? It is 6. So I'm going to write 1 minus cosine of 6x divided by 2. I'm going to write 1 over 2 separate and cosine of 6x over 2 separate. Integration of half is half x, and the minus half I will write. Integration of cosine 6x is sine of 6x divided by 6 plus c. So the final answer comes to me half x minus 1 over 12 sine of 6x plus c. Then I go to the C part. C part is, he gave us integration of 1 plus tan square 2x. You all remember the Pythagorean identity. 1 plus tan square of x is equals to what? 1 plus tan square of x is equal to secant square of x. Keep the same argument, which is 2x. I'm going to write secant squared 2x d of x, and the integration of secant squared is, everyone remembers, tan of 2x divided by 2, because my linear argument has to be divided by 2, so plus c. Next, we give you e part, sine square of x and cosine square of x d of x. Yes, in order to solve this type of a question, I need to think about the double angle identities. Guys, do you still remember the double angle identity which we took for the sine? That was sine 2x is equals to 2 sine x cosine of x. So let's try to apply that identity over there. Okay, I'm gonna try to apply this rule here. So I want here 4. I'll tell you what I'm gonna do. I'm gonna write it here. 1/4 sine square of x cosine square of x. Now, can I write all of them in one square form? It will be written like that. Then, then this will be changed into sine of 2x, because we took it that the double angle identity for 2 sine x cosine of x is sine 2x. Keep the square on it. And whenever you have a square on the top, you have to use the half angle identity, which is, yes, come on, 1 minus cosine of, if it is 2x, I have to write 4x divided by 2 d of x. Now I will write separately 1/2 minus cosine of 4x over 2 d of x. The integration of this thing is half x, and the integration of this is 1/2 sine of 4x divided by 4 plus c. 1/4 times 1/2x minus 1/8 sine of 4x, and now you can multiply 1/4 inside. Will give you 1/8x minus 1/32 sine of 4x plus c. So the question is longer, but I hope you understand it well. A, B, C, D. I think I didn't do this, but let me do the D part also, because I missed out this D part, sine of x, and this is cosine of x. I'm going to multiply and divide by 2. So this is 1/2, and 2 sine x cosine x is basically equal to sine of 2x, and the integration of sine 2x is minus cosine of 2x divided by 2 plus c. Final answer minus 1/4 cosine of 2x plus c. Last part, which is f, and this is very, very important question. Sine x plus cosine of x whole squared d of x. Can I open the brackets? Sine square of x plus cosine square of x plus 2 sine x cosine of x. When I open the brackets, everyone remembers this is equals to Pythagorean identity, it is equal to 1, and this thing is equal to sine of 2x. Integration of 1 is x. Integration of sine 2x is minus cosine of 2x divided by 2 plus c. And my final answer is x minus half cosine of 2x plus c. So I'm done with all type of questions here. Now we go to the question number 7. This is application part. We need to find the area bounded by secant square of x, right? Between pi by 6 and pi by 3. So area is is equals to, this is pi by 6 to pi by 3, and this is secant square of x. Everyone remembers integration of secant square of x is tan of x, upper limit, lower limit, upper limit substitute, minus lower limit, and 60 is under root 3, and tan 30 degree is 1 over under root 3, and that's all with this, the square units. Now, question number 8. show that left hand side it equals to this right hand side. Let's try. A part, sine x plus 5 cosine of x whole squared. Let me write this bracket 2 times. Multiply them. Multiply them. I hope that starts working. There is a glitch. So shall we write here? I don't know what is the problem happening. Going to close it and open it again. Yes, we were here. So multiply sine x with sine x, it gives you sine square of x, and then 5 sine x cosine x, then again 5 sine x cosine x, then 5 times 5 is 25 cosine square of x. Now this is sine square of x. 5 plus 5 sine x cosine x is 10 sine x cosine of x plus 25 cosine square of x. Is this the result I wanted to get? No, he has made sine to x. So it means this result and this result has to be replaced into the half angle identities. So this result was equals to 1 plus 1 minus cosine of 2x divided by 2, right? And this can be written as 5 times 2 sine of x cosine of x 25, and cosine square x can be written as 1 plus cosine of 2x divided by 2. Then I'm going to write it as 1 over 2 minus half cosine of 2x plus 5, and this is how much? Sine of 2x, and this is 25 over 2 plus 25 over 2 cosine of 2x. So what is half plus 25 over 2? It is 13. And what is minus half plus 5 over 2? It gives you 12. So plus 12 sine of 2x and 5 sine of 2x. Yes, this is the same thing which we want to get, guys. Yep. Now he says, can you use the previous result and try to evaluate it? So the B part is he says from 0 to pi by 2 sine of x plus 5 sine of x squared p of x. Just a moment ago, we did this. It came equal to 13 plus 5 sine 2x plus 12 cosine of 2x. Now we do the integration. Integration of 13x plus 5 minus cosine 2x divided by 2 plus 12 sine of 2x divided by 2, upper limit and lower limit. Upper limit is 13 times pi over 2 minus 5 over 2 cosine of 2 pi over 2 plus 6 sine of 2 pi over 2 minus 13 0 minus 5 over 2 sine of 2 times 0 plus sine of 2 times 0. This is 6. Pi over 2. Pi over 2 cosine of pi is minus 1. 2 cancels. 6 sine of pi is 0. 13, this is 0. Cosine of 0 is 1. Pi over 2. And sine 0 is 0. Final answer is 13 pi over 2 plus 5 over 2 and plus 5 over 2. Give you 13 pi over 2 plus give you how much? 10 over 2, which is 5. So 13 pi over 2 plus 5 is the final answer. Now, guys, further integration started, inshallah. In my next video, I will prepare the further integration. For this section, the most important things are the basic techniques which I have covered with you. Thank you, guys. Assalamu alaikum.